So today we are going to start with the thermodynamic cycle, and in the process of solving a problem there we will also further move in solving the numericals. Okay, we'll see the formula as well simultaneously. So as I've said, we are going to discuss a problem based on thermodynamic cycle. Now before getting started into the thermodynamic cycle, let's have a look on this TS diagram. Now what is that? What are the components we have? We are having the basic 5 important components, starting with the diffuser, compressor, combustion chamber, turbine and nozzle. 5 important. Now what happens at a diffuser? The air gets sucked into the diffuser, then that when it gets sucked, that air is moved to the compressor, where it get high pressure, the air get compressed, then that compressed air further moved to the combustion chamber, where all kind of ignition process takes place, or we can say in other word, the heat addition process is handled by this combustion. Now at the end, what we can see in the turbine, the hot air gases leaves to the turbine blades and enter into the nozzle, which helps to provide a better kinetic energy or increase in kinetic energy, and that's how we can able to propel the aircraft forward. Okay, so that's how actually the velocity increases and leads to create a thrust. So these are the basic layouts of the component of this gas turbine. Now mathematically, now we will see what are their efficiencies, and we will see how we can solve a problem, or based on the certain values. Okay, based on the certain value, how we can obtain. Let's take an example of this problem. Okay, now in front of you I have given one problem. So what was the problem? They have given a simple turbojet with operating and inlet temperature. Now we will solve this problem. Before coming to this problem, I would like to highlight few important things in this TS diagram. Now what is mean by TS diagram? T stands for temperature. Okay, temperature. S stands for entropy. What is entropy? Entropy defines the randomness. Now this particular graph, or you can say the graphical representation of what is happening inside the gas turbine, it's not a ideal one, it's an actual one. And the dotted line which you can representing this dotted line, these are the ideal one. So this is a combination of both ideal and dotted lines are the ideal one, and the thick solid line are the actual one. Now already I have defined how we can measure the efficiency. Now why it is very important to measure efficiency? Because any engine, they are not 100% efficient. There is some amount of losses. It can be any type of losses that it can handle. So now here we are going to see how the losses, how we can estimate the losses. So here I have made a shortcut to find out the efficiency of this 5 component. Now first and foremost, the easy way to remember the efficiency of a diffuser. So in a same side, diffuser and compressor is located. So if I want to find the diffuser, eta D, and if you want to find compressor, eta C. Now one way to remember, when we are identifying or when we are finding out the efficiency, eta, these are eta, alright. So eta means it's a relation between the change in temperature on either maybe either the ideal change in temperature or the actual change in temperature. So for this both the side, remember it's I by A, here also I by A. Now what does it mean? The ideal change in temperature to the actual change in temperature. Here also, if I want to consider for diffuser, that means a change between this and this. Alright, so change, suppose if I want to find, so I can say T0 or TA, anything. Ideal is represented by this phi. So T naught 1 prime by T naught by T naught 1. So this will represent the efficiency of a diffuser. Similarly, to find out the efficiency of the compressor, what is that? Ideal by actual. Now what is the ideal here? So ideal here is, this is the ideal, this is the actual. Okay, this is the ideal, this is the actual. So we are going to keep this T naught 1 constant with T naught 2 prime, T naught 1 is T naught 2. Now you can also write in this way, either of it, it's going to serve the purpose. It's not going to make much difference. Now this is for the diffuser and I have explained for the compressor. Now how to remember for the turbine and the nozzle? To solve the problem, these tricks are going to help you. Eta T, so just recall this A by I. So this is actual by ideal, and again eta nozzle is going to be actual by ideal. So it's just a reverse case on both the diffuser and compressor, what you can see for the turbine and the nozzle. Fine. Now here when you want to find actual by ideal, what does that mean? Difference in temperature. So when you are finding this, this is the prime or the dash is actual one, sorry, ideal one, and without dash is a actual one. So this is the ideal and this is the actual. Now you can simply write down the formula here. T naught 3 minus actual we have, so T naught 4 divided by T naught 3 minus T naught 4 prime or dash. So similarly for the nozzle you can write, so it is between these two zone. So T naught 4 minus T naught actual, T naught 5, and T naught 4 minus T naught 5 dash. Now for compressor it is different, because compressor efficiency depends on the fuel, how much amount of fuel has been consumed.
Ma'am,
Okay. Yes, please.
for efficiency of diffuser, it will be T naught 1 dash minus TA, na ma'am?
Yes, anything. See, either of that, it's going to be serve the purpose. You can do anything, because
Okay.
this minus and minus will get cancelled off, so that will
Okay,
not
ma'am.
affect. Okay, that, but follow the same way. However you are writing, you have to follow that path,
Okay, ma'am.
right? Okay. Now eta cc means it is the combustion efficiency, or sometimes we call as a burner efficiency. There are lot many names for the, or maybe combustor. So here it is actually the relation between fuel fraction to air of a theoretical. Here something different, because it's deal with the what is amount of fuel fraction is happening over here. So fuel to air with the actual. Okay. So in the process of solving problem, we will also further see the what is the difference in the, we will get to see lot many problems. Okay. Now let's get started. A simple turbojet unit operates with a maximum turbine inlet temperature of 1200 Kelvin, a pressure ratio of 4.25:1, and a mass flow rate they have given 25 kg per second under design condition. Now following component efficiencies are assumed. So compressor, turbine, nozzle, transmission, combustion pressure, combustion chamber loss, pressure loss has been given. They have also given, assume the specific heat with constant pressure for a air, for a gas. They have given gamma value, they have given during air. When it is converting to gas, they have given the gamma value. What are the parameters we have to calculate? Calculate the total design thrust. So here we will see what is the equation of a thrust. we will also see how to calculate the total thrust, and so you can see there is a difference in total design thrust and total thrust. That also we will see that formula, and specific fuel consumption. Okay, and that specific fuel consumption we will need to consider that nozzle choking condition. So at what point and what are the consideration that we can assume that nozzle is choked? So what are the conditions, that also you will get to know from here. Then assuming that unit is stationary at a sea level where so and so things parameters has been given, assume the air fuel ratio of 50. So they have given a quite a few parameters, and from this parameter we need to find out the following things. Okay. Now, so I hope you have noted down the given data. First, what you have to do is first note down the given data. Okay. Now, whenever they are giving you this,
can you please go the question home again?
oh, all right, okay. Now, whenever you are solving any problem, okay, first of all, if you see this is a from turbojet or some kind of efficiency is given, and they have given so and so parameter. First and foremost, your job is to draw the TS diagram. First and foremost, just without anything, without any hesitation, you just draw the TS diagram. Okay. Now, when you are making a sketch, just ensure the points. This is a point or 0 point, any point you can consider. This is 0,1 point, this is 0,2 point, this is the third point, the fourth point, and this is a fifth point. Okay, now you know what are these points, that you are well aware of that points. Now you just make the rough sketch of this, of your what we have seen just now. Okay. Now this dash are your ideal points. Fine. Now after that you have to understand what is this given data. That means what is the value they have given. Maximum turbine inlet temperature is 1200 Kelvin. So which point they have given? This point, this point, this point. So if temperature I am denoting by T, so what should I write here? What is this value has been given? This is very important to understand.
T03, man.
T03, very good, because this is a point, it's a maximum temperature, that you have to understand it. So 3 is a point, is a maximum temperature. So lot many ways they can describe this point. They can say the maximum temperature alone. They can also say TIT. Okay, TIT. What is TIT? Turbine inlet temperature. Okay, TIT is nothing but turbine inlet temperature. So they can define as TIT. They can also define the exit of combustion chamber. So this is a point of exit of combustion chamber as well. So first you need to identify your given data. Then RC is given, which we can call as a compression ratio. So what is a compression ratio? P02 by P01. So this value is given to you. Mass flow rate of air, that is M dot A. M dot A is given. Then they have given you eta C. So please kindly note down the given data in your notebook. Eta C, eta T, eta N, eta trans. Just write trans. I will show you what are the formula. We will discuss that. In addition, they have given you CPA. That means until and unless it started to complete a combustion, so all these points you are going to use CPA, and gamma value is 1.4. Once you started calculating the parameters for point that is third point, fourth point, fifth point, you need to use this formula. And very importantly, ensure with the units. Here they have given kilojoule per kg Kelvin. You have to be very careful with your units. Now further they have given few more parameters. Some ambient condition they have provided. Okay, that is P01 and PA they have given, and they have given TA value or T0 value, anything you can consider. Here some more parameter is given, A by F. They said it is 50. A by F, it's 50. Fine.
And this A by F is actual or theoretical?
We will see when what kind of formula we need. So if that, because they have not given combustion efficiency, right? So we will get to see that where we can use, and may not be applicable all the time. So this also you have to ensure that whatever the given data, sometimes what happen, we don't require all the given data as well. Okay, so we will see where we need this data. Fine. Basically, as they have not mentioned here, so one more thing you have to implement. See, what is the formula? I said theoretical by actual, I said, but eta Cc I have said F by A theoretical, right, and F by A actual. Now they have not mentioned whether it's theoretical. Now there is another way you can find out this. That is, you can also write that mass flow rate of air by mass flow rate of fuel is 50. So they have provided here your mass flow rate of your air is provided. Now can you find out mass flow rate of fuel? You can also find, isn't it? So you have to see the loophole, what kind of questions I am trying to make you confuse, right? So we will see how we can make use of each and everything and what is required and what will not be. Now first and foremost, see here, to proceed, as we have made a general sketch, but anywhere in this question did they ever mention about diffuser? Did they ever mention about diffuser efficiency or something, or pressure, or any difference with T0A with T01? Did they provided any question with that? They have provided, or how we can find out that? So in this particular problem, as they have not stated, and also they have not given the what is the flight speed also. Okay, so as they have not given, please note down this important point. They have not provided any data of diffuser. In this particular problem, they have not provided any data of a diffuser starting from efficiency. Okay, so two ways, either we can take diffuser is 100%, or second thing we can consider T0A is equal to T01. Obviously if it becomes 100%, so this is what we have to take, right? This is what we have to take. Are you able to get my point? Now many of the times I have seen, see, as in the starting of the problem you know how to solve it, but as a first itself you see that there is a no diffuser, so you just pull your head and pull your hair that how can I proceed if the data is not given, they have given other data. Now what first it comes to students' mind that this is a wrong question, so if I attend or does not attend doesn't matter, so I will get a marks. Such kind of thoughts most of the time it appears. But you have to be ensured with this parameter. So you have to also follow the step. If where is my slider? Yeah. If flight velocity is given, okay, if I write Vi, then you can find out what is eta d, that is a diffuser efficiency. If flight speed is not given, you can directly assume that it is 100% and T equals to T01. Any question here? Any question? Anyone? From anyone?
No, ma'am.
Right. Okay. So we can move to the next step. Now, as in the given data, we can also consider that T01, that is T01 or T0A, is equivalent to 293 Kelvin. So the value which they have given is same as T01, and that means the P1 is also the P0A equals to P01, that is 1 bar. Clear? Now let's move to the next slide and proceed. So I hope you have noted down all the formulas that you have to proceed. Now first and foremost, we'll start with the compressor, as diffuser is not there. Now just now I have said what is the formula. I said ideal by actual. Now during your exam or when you're practicing, you follow the same step while solving. So you will remember this tips to your lifelong. So we don't have this point, so we can simply ignore it. Now what is I? I is the ideal one. So T01 and T01 will keep it minus ideal is T02 prime, and here also T02. I can simply write this. Now I know in the given data we have T01. Okay, but we don't have neither T02 neither T0 prime. But we know what is isentropic relation. Isentropic relation. What is that isentropic relation says? It's a ratio between T02 prime by T01.
T01, P0.
Very good.
P02 by P01, gamma minus 1 divided by gamma.
Very good. And what we know, this P02 by P01 is also known as RC.
Yes, ma'am.
Is known as RC, isn't it? Now this value is known, that RC value is provided in our question. Gamma value is known. Then T01 value is also known. Can you find
Yes,
T02 prime?
Yes, ma'am. Definitely.
Find out and quickly tell me the answer. So we will move to the next. See, if you can remember, because I personally don't suggest to remember, I do suggest you to remember, because you know there are many efficiencies are there. It's really sometimes confusing. But if you follow this kind of step, so you can avoid silly mistake and you can score complete full marks. That is my policy. So that's why there is a complete formula, isn't it? I hope you have, you might be remembering this. T01, something like RC power gamma minus 1 by gamma, completely minus 1. Then here you have T0, you have 2 minus T01. Okay, this is a complete formula of efficiency. But if you want to use, sometimes very confusing whether it's T01 or T02, whether 1 minus of gamma RC, something confusing. To avoid that, follow the general step and it will go in the right track. Fine. Now have you
Yes,
found out this T02 prime?
Ma'am, I late ma'am joining ma'am now. I know my person know any questions.
Okay, so after you find out this T02, you just need to substitute back to this old equation. So
Yes,
in that
ma'am.
old equation,
This efficiency after the time, ma'am.
efficiency is known, T01 is known, then from here you just found T naught 2 prime, you will get it, and after solving you will get to know the value what is T naught 2 in terms of Kelvin.
Ma'am, dinner 2 is ma'am
It's actual one.
low temperature. It's low temperature na ma'am. Comparison to dinner 03, dinner 3.
T naught 3, yes, compared to T naught
Dinner
3 it is low,
3 is the
absolutely
highest.
right. Highest point
Yes,
is
ma'am.
3.
Is dinner 3, ma'am.
Yes.
And low point, ma'am, is the dinner 2, I think, ma'am.
Yes, this is a T naught 3 is the highest. Okay, and
Yes,
lowest
ma'am.
is T naught 2 is compared with the 3.
Yes, ma'am. Many times ask ma'am these questions, ma'am.
Yes, absolutely. So, is there anyone who have completed this answer? Can anybody unmute and say
443.00.
which one? 4
Ma'am,
T
2
naught 2
prime
prime.
is equal to 442.98 Kelvin.
Okay, okay. You tell me this T naught 2 alone.
T naught 2.
Yeah.
No, ma'am, I have found T naught 2 prime, ma'am. I haven't found out.
Okay. Find out and tell me that answer.
Okay, ma'am.
T naught 2 prime.
Hello.
Yes. Are you getting this answer? 465.63.
Ma'am, T naught two was not 464.0.
Yes, exactly. That's what I've written here. 465.63. Close to that answer. Follow?
Yes, ma'am.
Right. Now next what they have given, turbine, nozzle and transmission. Okay. The transmission is a combination of a component where we need a combination of this compressor and the combustion chamber. Okay. So the relation of that is something like this. So simultaneously note down the formula as well. Okay, that's the purpose of solving the problem. So transmission formula is something, it's a ratio between the compressor work done by how much heat output by this combustion chamber. So how we can write it? CPA T naught 2 minus T naught 1. Okay, change in this. That is a work done by the compressor. Another one is what is the heat transfer by this or heat input in the combustion chamber. So as here there is already, when there is ignition process, the air and fuel get mixed. So we here will have gases. Just now I have said here we'll use the gases. So CPG T naught 3 minus T naught 4. Remember this formula. So for the transmission, it's between the compressor and the combustion chamber. Now in case in a question they have not provided a separate value for CPA and CPG, no data has been provided. In that case, what will be that? On that case you can simply take the value which they have provided.
And if it is not wet, then after the CP by CPG,
Yes,
may I
take that.
put the 1, ma'am.
Yes, you can take the value will be 1.005. Now when you are substituting here, as both in the numerator and the denominator we have the same value, so things will get cancelled. But look into the unit, what they have given here. They have given here is 1.005 kilojoule per kg Kelvin. So that you need to convert it, fine, into 10 power 3.
Yes, ma'am.
So
Yes, ma'am.
most of you fail to use that. So have a practice of converting the unit. Okay.
No, ma'am. I convert, ma'am. If a kg have per Kelvin, ma'am, to convert, ma'am, kilomole. I divide by
Right. Okay.
1000.
Right. So after that you have this efficiency of this transmission. You have this value. You know what is T02. Just now you got it. What is T02? You have the value of T01. Now you see T03 already given in the question. So this is also you have. Now what is unknown? Unknown is T04. So can you find out T04 using this relation?
Ma'am, T04, ma'am, I think, ma'am, actually, ma'am, T02 equal to, ma'am.
Sorry?
T02 equal to, ma'am, T04, ma'am.
T0.
T01 equal to T05, ma'am.
No. Never. No. In ideal,
Hello, ma'am.
yes, it is in real case. It is not at all. See here, what you are solving is an real case. So real case, it's never equal. Okay? They're never equal. Remember, there is a difference between real, that means actual, versus ideal. Here you are solving a real one, real case. Kindly mute. I request others to be, please keep yourself mute. If you have any
Yes,
question, then you unmute and ask. And after you got the answer, and you just keep yourself in a mute mode. So as the session is recording, so you will get a better clarity when you're referring back as well. Any confusion over here? Shall I proceed? Now you need to tell me the answer. So that will be more better if you simultaneously give me the answer.
Then I put, ma'am, after that, ma'am, T03, T04, T04 minus T03, ma'am. Similar is formula I make, ma'am.
So what is the
T04.
answer? Just check your answer. Something like this.
Yes, ma'am.
Ma'am, 1046.44 Kelvin.
Okay, 0.44. You're getting. Alright. So you're getting close to this answer. Right? Now you got all the points here. These points you got. Now what else they have given? Now you have reached to this combustion. Now you have reached to the point of turbine as well. Now turbine efficiency they have given or not? They are provided.
Yes, ma'am.
Okay. Now to find turbine efficiency, what is the formula I have said? It is the actual by ideal. Now actual, what is mean by actual? Let's take T03 common on both the side. Okay, that means on the numerator and denominator. Ideal in the sense T04, and here you have T04 prime, a dash. This is the general formula for a turbine. And here in this question they have given you what is a turbine efficiency, 91.5%. They have provided. Okay. Now what is the unknown from here? This is known.
T04 dash.
Very good. So easily you can find what is a T04 dash.
Yes, ma'am. But only if, ma'am, diagram, ma'am, and profile is remembered, then automatically, ma'am,
Yes.
formula is make, ma'am.
Yes, absolutely. You need to remember this graph and automatically you can solve it. Now remember here we have calculated this value, but have we calculated what is the P02 value? They have given the RC value. What is RC? RC is a pressure ratio. That is a P02 by P01. P01 value
Yes,
is
sir.
known. RC value is known. So from here you can find what is P02. Right?
Yes, ma'am.
You can find what is P02 in terms of bar. In terms of bar you can find out.
Ma'am, P0 2 also, ma'am, is the lowest pressure, ma'am, comparison to
No.
exhaust.
P naught 2 will give the maximum pressure compared with all. This graph, what you are seeing, is for temperature versus entropy. Okay. So if you see the pressure versus volume, okay, so that time you can see that this is a point, that is a compressor is a point where you have the maximum pressure. Please note that point, maximum pressure. So you can
Yes,
find
ma'am.
out what is the value for this P naught 2 and you can answer for it.
In a TL diagram, ma'am, where is, ma'am, lowest pressure and higher pressure, ma'am? Which point, ma'am?
Highest temperature is in the point 3. Note down, highest temperature is a point 3
Yes, ma'am.
and highest
This is
pressure highest pressure is in point 2 and highest velocity is in point 5.
ma'am, low pressure. Where is, ma'am?
Low pressure comparatively,
Where is, ma'am? Which point?
it is very difficult to say where. It depends on the scenario, but if you give a near about close look, so maybe at the point inlet or the exit, okay, exit of the nozzle or the inlet of the compressor or the diffuser, there will be the least value.
Yes, ma'am.
T04 dash is, ma'am, 1198.
1000.
198.3.
Fine. All right, now you got this value. Now T02 value, T04 and T04 prime. Now
How much, ma'am? That value, ma'am. How much? How to ma'am that value, ma'am?
so we got few more parameters. Now here I have said that what is a pressure. I hope you have found out. So maybe 4.25 because P01 is 1 bar and RC is 4.25, which is given in the question. So obviously you will get 4.25 bar for this pressure. Fine. Now remember one more thing they have given here is a combustion pressure loss is 0.21 bar. So
Yes, ma'am. This is
that means you need to find what. Yes, so that means you need to find what is the relation between P02 and P03. So
Ma'am,
for yes, please.
P02 value will be greater than P01, no, ma'am.
P02 will be greater than P01. Yes, absolutely.
Okay, ma'am. Okay, ma'am.
Right? Okay.
Okay.
Now, how we can find out this P03 or P04 or other parameter? So we can again make a use of this eta t, or you can also use isentropic relation. Now what is this isentropic relation that you can use? T04 prime by T03 equals to P04 by P03. Okay, gamma minus 1 by gamma. Now in other way around, what we can write is P03 by P04 is a pressure ratio of a turbine within the turbine. Okay, so we can write as R suffix T, P03 by P04. Now as in this situation, can I find out this P03 by P04? Now use this relation. Can you find any of the unknown value? Any one of the unknown value. T04 prime is known, T03 is known. This gamma. Now here using the in this gamma, which gamma value will you use? 1.4 or 1.33?
1.33 में.
Absolutely. So here the gamma value you are going to use 1.33, isn't it? So can you find RT then? So you will know what is the value of RT. Okay, I just lost my else. Where is my sliders? Oh, right here. Okay. So you just use this formula and find what is the value of RT and ensure this gamma you are using as 1.3 here. So what is RT? P0 3 by P0 4. P0 3 by P0 4. Tell me what is the value you are getting. Then I will proceed to the next. Once you're done, just tell me. Is it done? Am I audible?
Yes, ma'am.
Okay,
Yes.
I just thought again I lost the connectivity. Once you're done, just let me know.
Ma'am, it is 0.54, ma'am.
Just let me check the answer. 0.54. No.
Ma'am, I am getting 0.96.
0.96. That's not a right answer.
Ma'am, 1.83.
Absolutely. That's the answer. 1.83 is the answer. Actually 84. Kindly check your answer. See, what I asked, RT is the inverse of that. P0 4 by P0 3. Okay. Now, here in this question, they have said that there is some pressure loss. Now, what if there is no pressure loss? That means at this point 2 and point 3, it's going to be the same pressure as per this Brighton cycle, isn't it? So, if I draw this curve for pressure versus your volume, so it's going to be the same. But here there is some amount of loss. So how we can write that loss in terms of mathematical form? So we can write this 1.84 equals to P03 by P04, which can be further written like P02 minus the amount of the pressure loss by P04. Now here we know what is P02. We know what is P02, that is 4.25, and what is amount of loss? They have given 0.21 bar, that is amount of loss, 0.21 bar. All are in bar, so I am not converting it. Do we have any value of P04? We don't have. So we can simply take P04 by 1.84 to we can get what is the value of P04. What is the pressure for the P04 in terms of bar. So if you have found out the value, kindly recap and see that what we have done here.
And 2.19.
Okay, just let me check the answer. 2.19. Okay, it's 2.19 bar. Now, till now we have the pressure and temperature for 1 point, pressure and temperature for 2 point, pressure and we have pressure and temperature for third point as well as a fourth point, right? But still we have not reached the destination. What is our destination? To find out the thrust. So how we can find the thrust? Now for that we need to complete one more parameter called nozzle parameter.
How del P is equal to 0.01, ma'am? I didn't understand that point, ma'am.
Okay, point, this has already been given, dear. See, it is given in the question.
Okay, ma'am. Okay.
Okay, it has already been given in the question. That's how. Now we have found out all the majority of the component. Now it's time to find for the nozzle. Now if you see in your given data, they have given some value of a nozzle, like some percentage efficiency value of a nozzle. Now again I said, what is the formula for this nozzle efficiency? It's again actual by ideal. Now if you relate this, how you can relate? T04 by T04 minus T05 minus T05 prime. Simple way. And previously from the previous data you got all the values. You have the value of T04, you have the value of eta n, but you don't have any value for neither for T5 or T05 prime. Do you have any value? Do you have any value?
No, ma'am.
No. Now let's look into the other way around. Like let's take into isentropic relation. Now if I have to take this isentropic relation between this 0.4 and 0.5, what will I get? So I will do this T04 by T04 prime. Now what will be the pressure ratio then? P04 by P05 power gamma, this gamma minus 1 by gamma. Here the gamma value, which gamma value will I use? 1.33 we are going to use. T04 is known, P04 we have it is known. Do you have any clue what is P05? What is P05?
Ma'am, we have to consider it choked, right?
See, that condition is different. They have not said that. First we have to check whether it is choked or not, and then if choked, then what is the thrust. That we will see that. Okay, I will come to that part as well. But before finding choke, how will you find this P05?
It will be gamma by gamma minus 1, no, ma'am.
Which one? This one?
P04 by P05, the whole power.
No. Just check previously what you have done. Check it once again. It's gamma minus 1 by gamma. Kindly check that. Gamma minus 1 by gamma. Now as this point, when this there is a huge amount of kinetic energy, this hot air gases will expel out to the atmosphere. So can I say this P05 pressure is going to be the same as a ambient condition, what we have taken as P01. Alright, if they have not given, so in that case we have to take this as a consideration. That does not mean that T01 is going to be same as T05. It's not. Okay, so you have to apply this principle over here. So using this principle, that is T naught 4 by P naught 1 power gamma minus 1 by gamma. So you have the value for P naught 1, that is 1 bar they have given. P naught 4 previously you have found out, and T naught 5 you can easily find out the value. Now once you find out, then we will move how to find out for this choking and other condition. Complete this.
Ma'am,
Yes, please.
in the last case, we have taken that T naught 4 prime by T naught 3 is equal to P naught 4 by P naught 3 the whole power gamma minus 1 by gamma, ma'am.
Can you hear?
Yes, ma'am. Sure.
See, gamma minus 1 by gamma only, na?
Ma'am, but here it will come gamma by gamma minus 1, ma'am, in in the next relation.
Why so, dear?
Ma'am, because
No. It is just a relation between this temperature versus pressure. Just a second. It's just a relation between temperature versus pressure. See, here also we have 4, here also 4. 3, here 3. Isn't it? Here also 4, 4, 5, 5.
okay, ma'am.
It's not going to make any changes. I hope I made you clear.
Yes, ma'am, clear, ma'am.
Fine. Now, can anybody tell me what will be this value of this T naught 5? T naught 5 prime.
T naught 5 prime is 861.97.
19.
Yes, ma'am. 861.
861 point.
0.97.
Okay, 0.97. All right. Okay. So this is the value you are getting. So is there any other parameters that is pending? You got P naught 5 is pending, isn't it? Anything is there? Anything is pending?
And one confusion, and these problems are very lengthy, so I waste much time.
No,
for
dear,
it.
no, dear, no. The reason behind this time I'm solving because last time they have given lengthy, very lengthy. For an example, you have seen in structures, you need to find for your thin wall structure, like both the sections you have to find, and you have to compile this beta value, that is at angle of twist and all that. So it takes around for 16 mark question or 10 marks question. How you answered the same thing last time, the question paper was same ditto likewise. Only thing is there was an option, and in your finals subjective type there is to be no option. So that's why if you have the clarity on solving this thing, so however way they ask a question, you should able to attain it. That's my motto. You're getting my point? Because
Yes.
that's, and we don't worry, if you can solve this problem, okay, proper see, these only thing you need to remember is a formula. Just keep on applying, but if you make any silly mistake, then it will go wrong. Fine. So that's the main motto of doing this. Right. Now I think T05 is missing. We have done everything. T05 is missing. So you can simply substitute this value T05 prime value here, and you can find what is the value of T05. Okay, now after you complete this, now let's look into the first thing, total design thrust. So for the
Hello,
total,
ma'am.
yes please.
I am asking ma'am how to get ma'am pressure ma'am. I confused about pressure ma'am.
Which pressure?
So peanut 5 ma'am. How do you got ma'am peanut 5 ma'am?
See, P05, what I have taken is, as this hot air gases are expelling out from the nozzle. So after it expel out, where it will go? It will come and merge into the atmosphere.
Yes ma'am.
So that's why the P05 value will be same as the ambient pressure which they have given in the question here.
But before I'm asked is similar as like ma'am, but you are speak is not equal to pressure ma'am.
No. See what I said, as they have not given, so it can be different as well. Okay, now you need to give a check. Now you have to give a check if it is equal, whether it will be choking or it will not be choking. You need to analyze that as well.
Yes ma'am.
Right, based on this configuration you have to see that, and based on this parameter the thrust value will also change. But okay, so just find out this. Now what is the first and foremost?
868.42 ma'am. 68.42 Kelvin.
Okay, fine. So you got all the things right now. Now first and foremost, to find out if they are asking any question like design thrust. Okay, T, it is nothing but m dot a into velocity, exit velocity. Now how we can find exit velocity? Based on the formula 2 into CPG into TE. Okay, TE. Now how we can find TE again? What is TE? Any guess? What can be TE?
Exit temperature.
It's a
Exit
difference.
temperature.
Exit temperature. How we can find the difference between T04 minus T05? Okay, here TE refers T04 minus T05. Now you have both the factors. You have this, you have this, you have this as well. Okay, then you substitute here. Then you have this m dot a, which is given in the question. I think 25 they have given in the question. Substitute, you will get to see what is a design thrust. Okay,
Ma'am,
please.
here why we are taking the actual condition, ma'am? Like it can be T04 prime also, no, ma'am, for it to find exit temperature.
Very good question. Now there is one relation between this in the nozzle phase. The relation is something like, so difference in there T04 minus T0. You can say there is a relation between this is called as an stagnation and static relation. Okay, this formula is something like this: V E square by 2CP. Some kind of relation is there. So this formula actually derived from there. Okay, so T04 minus T05 equals to VE square by 2CP. Now if I convert this, what is VE square equals to 2CP T04 minus T05. So change this square and convert them in root. You will get exact the same which I have explained.
Ma'am, please, ma'am, again, ma'am, explain TE, ma'am.
T is nothing but it's a difference between this two phase, like the inlet of the nozzle and the exit of the nozzle. What is the temperature difference? Okay. Now why I have came to this part, if you know when you're doing a mock test, just a second, let me complete this part. They have asked a question like the inlet of the nozzle and the exit of the nozzle and find out the thrust, and they have given the mass flow rate. Now in that condition, if you know this entire process, then you will know that clearly which formula you have to use. They have given the Cp, they have given the mass flow rate, they have given the difference of the temperature, and they ask that what will be the thrust value. So once you are able to calculate the velocity from here, you substitute there and you will get the thrust. Okay. If you are not doing the complete sets of thing, then it's going to be very tedious for you to understand that why these other formulas, they have derivations. Okay, so that is not the concern. And similar kind of equation you can find from the basic of thermodynamics, like a steady flow energy equation. Okay, it also follows the same as a steady flow energy equation. Yeah, now you ask a question.
Ma'am, the stagnation and static relation, it will come like T01 by T1, 1 plus gamma minus 1 by 2 m square, like this.
Yes,
ma'am.
right.
When we have a T04 means the minus should be the T01, the T4.
See, actually, they consider this as a point as a 5 alone. They don't consider not. So that's not a main discussion here, like static and stagnation, right?
Ma'am, for T04 it should be T4, no ma'am. Why? How it become T5?
T04 should become
T4, no ma'am. T04 by T4 then is equal to 1 plus gamma minus 1 by 2 m. This is turbine section.
Okay. No. There is yes, that is one relation. You're talking about T04 by T4 equals to 1 minus gamma minus 1 plus gamma minus 1 by this formula you're talking about, right?
Yes ma'am, that will only become this V, no, because the Mach number is the exit velocity by
yes,
sound of
this is
speed.
one way we can write this. Another way we can also write this. That is a derivation. How we can transform this, like whatever the number it might be, we can transform this equation into this one. That is actually derivation. If I find that, you can find this derivation in, I will tell you the book. This compressible flow by Yaha something, M Yaha. Okay, you can find.
Derivation is there, but T4 it is there, ma'am. T5 it is not there.
No. It is there. You can see this. Right now, I don't remember the derivation. Okay, but it is there between this combination of this. Okay. There. And I think you can refer one more book, Saravana Muthu. I'm forgetting the name of the book. Gas turbine something. Okay, gas turbine, you can find Saravana Muthu. They have in detail derivations they have formed on this. Okay, now what I have said here we are just going to use the formula. You have to remember this formula, and you are not sure when and where they will ask. Now very importantly, as you he has just mentioned that sometimes they might give you this, they can mention the stagnation and static. Okay, if they mention something like inlet of a inlet temperature of a nozzle is something with a stagnation and static, then you also need to you might need to use this. Okay, so in the upcoming days I will show you some formula where you need a multiple formula. Okay, so you will get an idea where to use which formula. You will get used to it. Okay.
Ma'am, one question I asked, ma'am.
Yes, what question you asked?
I asked, ma'am, static and ma'am stagnation pressure, ma'am. Statics, ma'am, normal pressure, ma'am, and stagnation pressure. What the ma'am is the stiff pressure, ma'am? Where is the ma'am? Everything's it's
Everything.
not going any flow. That times is stagnation pressure, ma'am.
Yes. So stagnation means like suppose at there is one point, okay, there is one point, and in that point when the velocity is heating and it coming to rest, the velocity
Yes, ma'am.
coming to
Yes, ma'am.
at means becoming zero. So
Yes, ma'am. That time is
we call
my
as
stagnation
a,
pressure.
yes, that time we call as a stagnation pressure. Okay.
What? Yes, ma'am. Static pressure. What the ma'am? Normal pressure is the
Is
called
that
ma'am static pressure.
like what to say? It can be, we cannot say normal pressure. Um, it's like by the name you can say it is the when the fluid is in rest, like it's not moving, right? So that time we call as an static pressure.
Okay, ma'am. I discuss with balloon, ma'am. This
All
topic,
right,
ma'am.
okay. And there are like a lot many pressures are there. So right now you don't get confused with this static, dynamic. We have stagnation, how the relations. Okay. So we will have this session that how see, as of now I said that what is static pressure, talking about that that is at point at rest, right? Now you might think that if it is at rest, so what does that mean? It the stagnation also I'm telling it is at rest. So when we'll come to the pitot static tube, how to measure the things, so you will get an idea that what's the difference, prime difference between static and the stagnation, right? Okay, right. Okay. So now I think you have found out the what is that? Thrust. Have you found out that thrust value? Have you found out what is the thrust value using the formula? Yes or no? Am I audible? Am I audible?
Ma'am, 16 kilonewton, ma'am.
Okay, very good. 16 kilonewton. Now I think it's almost time, so quick, next class I will continue, but before that this nozzle choking part. So how we can find if the nozzle is choking or not choking? So there is a relation between P04 by P01, or ambient, you can say in general, ambient pressure. If this ratio is greater than P04 by PC. Okay, then how to find this PC? There is a formula to find this relation. There is a formula 1 by 1 minus 1 by eta nozzle gamma minus 1 by gamma plus 1 by gamma minus 1. There is a formula. Okay, so using this formula, yes please.
Eta, ma'am?
Yes, eta n
Eta.
nozzle,
Okay.
eta nozzle. This gamma is for the, obviously we'll use 1.33, and this is a gamma by gamma minus 1. Fine. So if this value comes lower than this one, at this condition is, that means the nozzle is choking. Now while practicing you will get to see that some of the questions they have asked the condition of the nozzle, whether it's over what is the condition, is it choked or not choked, what are the parameters. Sometimes they will give you MSQ type question, so what are the things, right answer you have to keep on tick the right one. Okay, so this is a way you can find out. So and then
So, ma'am, the R what, ma'am? That which procedure, ma'am?
so which one
The 1 minus 1 by nozzle efficiency. That R is there. No? R minus 1 by R plus 1.
no, this is not R, it's gamma.
Okay.
Sorry, it's gamma. Okay, gamma minus 1 by gamma plus 1. So these all are gamma, power gamma by gamma minus 1.
This gamma for combustion products or
Yes,
compression?
absolutely. I said now, once you're finding for the nozzle turbine, right, once it started from the combustion zone, so you have to use gases. Okay. So rest we will continue in tomorrow's class. Okay, tomorrow I have a very important meeting, so maybe I will take care on the Friday. All right.
Ma'am, one more question, ma'am.
Yeah,
If
please.
ambient pressure equal to